We're in Unit 3 Quadratics. This is Lesson 3.2, Quadratic Graphs and Their Properties. There are several objectives in this lesson. One is that you can solve for the axis of symmetry. There will be a formula for this. Explain that the parent function of a quadratic is the parabola f of x is equal to x squared. So whenever they're referring to a parent function, they're always referring to that formula, f of x is equal to x squared. You can explain that the minimum or maximum of a quadratic is called a vertex. Basically, a vertex is the minimum or maximum. Be able to identify whether the vertex is a maximum or a minimum just by looking at the equation. Find the y-intercept by substituting 0 for x and then evaluating it. And finally, estimating the vertex by evaluating different values for x. So several objectives. Before we start looking at quadratic polynomials, let's make sure we remember what one is. Which expression is a quadratic polynomial? Remember that quadratics are any polynomials whose highest degree is 2. So if we look at A, the highest degree is just 1. In B, the highest degree is 4. There we go. And C, the highest degree is 3. And D, the highest degree is 2. So D is our quadratic polynomial. In Algebra 1A, we looked at just linear polynomials. Remember that linear means the highest exponent would be just 1, and that would be A. A is it. Just realized we were still recording here. A parabola is the shape of a quadratic. Remember, a linear equation forms a straight line, but when your highest exponent is 2, you will always create this U-shaped curve called a parabola. Parabolas have some key features. The one key feature is that all parabolas are symmetrical. That means the same on both sides across what we call the axis of symmetry. It's this line right here. It splits the parabola in half. Now a parabola can either point up or point down. If the parabola is pointing up or the U-shape is going up, then the lowest point on the parabola is called a vertex or the minimum. If the parabola is pointing downwards, it's the highest point is the vertex or the maximum. So parabolas will always have a vertex, which is the minimum or maximum value of that U-shaped. But it depends on if the U-shape is going up or down. The way that you know this is looking at your A value or your coefficient of your x squared term. So right there or right there, the coefficient of the x squared term. If the coefficient is greater than 0, or basically if it's positive, so if your coefficient of a squared is positive, your u will always go up. If it's negative, for example, negative ax squared, your U-shape will always go down or your parabola will go down. Each type of algebraic function has its own family of possesses unique traits. If you want to understand the characteristics of each family, then you have to study its parent function, a template of the domain and range that extends to other members of the family. In Algebra 1A, when we were talking about linear equations, y equals x was our parent function. It created a graph that was a straight line that was going up at the origin of 0, 0. The parent function of a quadratic is this f of x equals x squared. Our x squared, what is its coefficient of this parent function? You don't see it. Hopefully you recognize that it should be 1. So the parent function of a quadratic would be going upward, or that U shape going up that we just learned about. Here you see the parent function on a graph. Just like the parent function of a linear equation, it will intersect that 0, 0 goes through the origin. So in the parent function, your vertex is at 0, 0. This is also where its y-intercept and x-intercept is located. So the y-intercept of the parent function is at 0, 0, and the x-intercept is at 0, 0. The line of symmetry, or the line that divides the parabola in half, is also on the y-axis. So that line of symmetry is at x is equal to 0. Remember that a straight vertical line equation is x is equal to a number. Here we have the vertex at 0, 0. That's this point right here. Here's that equation. The domain is all real numbers. Remember that the domain is all your x values. So we can go back and forth along the x-axis, and we will always land somewhere on the graph. There's no missed spots. The same is for the range. Remember that range is all real numbers greater than or equal to 0. So the range is limited. Range is your y values. Notice that there are no y values that are below 0 down here. There's none down there. So all your y values would have to be greater than or equal to 0. It's important to note on the parent function, the x and y intercept is only 1 point. Just like on linear equations, when we had an x or a y intercept, it was only 1 point. We're going to see something change when we go away from this parent function. You've probably heard of symmetry before, or learned about symmetry even as early as back as elementary school, when you put paint on a piece of paper and fold it over and opened it up and it made a butterfly, or maybe you cut half of a heart on a fold and you opened it up and it made a full heart. Symmetry is the mirror image. A figure has symmetry if it can be reflected over a line so that the two halves match exactly. Basically that fold. In math, when a figure can be reflected, or in other words folded, over a line, the line is known as the line of symmetry. The line of symmetry for a parabola is called the axis of symmetry. So axis of symmetry and line of symmetry are the same thing. An example in the figure above has both horizontal and vertical lines of symmetry. They can be folded on either one and they will line up exactly. Let's look at the 3 figures below and see if we can count how many lines of symmetry there are. In figure number 3, you can probably see that there is a line of symmetry, and sorry if my line is not super straight there, but right there, if we fold it in half there, then this would be the same on both sides. We could also draw a line of symmetry this way and it would fold down on top of each other. Or you could do a line of symmetry through here. So there we have 1, 2, 3 so far lines of symmetry. Here's a 4th one. This one actually has quite a bit, because even if you look on the diagonals, if you cut it straight through the 2 diagonals there, you'll notice that they're the same on both sides. So what are we're up to? 1, 2, 3, 4. There's 5. And you can do that on all the points. 6, 7, and 8. There's lots of them on that one. There's 8 lines of symmetry on that figure. On figure 4, there is no place on figure 4 where you can draw a line and you could fold it and it would be the same on both sides. So in figure 4 there's 0. On figure 5, and this hopefully you can now identify that this is a parabola, there's that U shape. The axis of symmetry or fold line would be right there. It folds that parabola in half, so there is one line of symmetry on a parabola. So the axis of symmetry is a line that divides the figure into two symmetrical parts in such a way that the figure on one side is the mirror image of the figure on the other side. The formula to solve for the axis of symmetry of a parabola is this. X is equal to the opposite of b all over 2a. Some people say negative b over 2a, but if you say opposite of b, then you'll know to always just change the sign of your b value. So let's practice this. It wants to know what is the axis of symmetry of the following quadratic. We don't have a graph here, so we can't just see it. We can use the formula though. In the figure above, what is our a value? A is equal to, well, a is always the value that's in front of our x squared, or the coefficient of x squared. So a is equal to 2. Your b value is always the coefficient of just your x to the first power, so that our b is 4. Use the formula below. X is equal to the opposite of b. So if b is positive 4, the opposite of b would be negative 4. All over 2 times a. 2 times our a value is 2. And you just simplify this. So negative 4 over 2 times 2 is 4. Negative 4 over positive 4 is equal to negative 1. So our axis of symmetry is equal to negative 1. If you were to graph this later on, if that was your graph, you would go over 1 and your vertex would be, or your axis of symmetry, which by the way, when we're graphing, our axis of symmetry we usually draw with a dashed line to show kind of like the folded line. That would be your axis of symmetry. Also, you can notice that our a value is positive, so from the earlier part of the lesson, hopefully you remember that that means that this parabola is going to go up. Now it may not look exactly like that because of the other numbers in the equation, but that's a general, if we were to do a rough sketch of this parabola, what it would look like. Here you have another parabola in the equation. Let's see if we can figure out what the axis of symmetry is on this one. Sure, with the picture of graph, you can clearly see that this divides the parabola in half, right there at the 3. So you know that x is equal to 3 is the axis of symmetry. Or we could use the equation. Remember the equation is x is equal to the opposite of b all over 2a. And we have the equation that or the parabola's equation up above here. Our a value is equal to negative 1. The b value is equal to the 6. So if we plugged it into the equation, x is equal to the opposite of b. Well, b is positive 6, so it should be a negative 6. All over 2 times a. So 2 times negative 1 is equal to negative 2. So negative 6 over negative 2 equals a positive 3. There you got this exact same answer. Yes, it's nice when they give you the graph, but make sure you can use the formula, remember the formula, to find the axis of symmetry. We'll try one more example. In this equation, your a value is equal to, I don't see a number in front of my x squared, but remember then that means it's 1. Your b value is negative 2. Don't forget those signs of the coefficients. Don't just say 2. Common mistake. So using the equation, x is equal to the opposite of b, which would be positive 2, all over 2 times a. Well, 2 times 1 is 2. Therefore, our axis of symmetry is at positive 1. Vertex is the high or low point of the graph, in which the point has a coordinate of h, k, or we usually use this as the letters hk to represent this point. We also call this the turning point. If you notice, the parabola starts going down and then goes back up again. It's the point where the direction changes. When you hear the word maximum, the maximum point in a parabola opening down, it is the point where the graph changes directions. If a is less than 0, basically it's negative, the parabola will open downwards. In this graph, in this picture, it's opening upwards. So this point that you see down here, right here, let's see, this point right here would be, sorry, it's not drawing for me, there we go. That point right there is the vertex, and that would be the minimum point. So minimum, the minimum point in a parabola opening upwards. It is the point where the graph changes if your a value is greater than 0. Basically, it's positive. Then the parabola will always open upwards, like in this picture. So there's the vertex minimum. So looking at this equation, will the following quadratic have a maximum or minimum value? The way you can tell is look at your coefficient of x squared. What is that coefficient? I see a positive 2. Because it's positive, then it would have to be a minimum. Because if it's positive, the U shape is going upwards, so that would be the lowest point, the vertex is the lowest point, or the minimum. In focus question 2, our a value is negative, so that means your graph is pointing downwards, and the vertex would be at its highest point, or the maximum. Remember that a vertex is a point. So in question number 5, what is the coordinates of the vertex of the graph? Well, look for this parabola is pointing upwards, so the minimum point would be the vertex, the turning point, right. Let's see if it'll let me mark here. Right there. So its coordinates, if the origin is right here, your x value would be at -2, and your y value is at -3. So looks like C would be your answer. Question 6, underline the correct word to complete each sentence. The vertex is in this example right here, is at its lowest point on the parabola. So the vertex is the minimum point of the graph. To calculate the vertex of any equation, we use the points h and k. Your h, or x value, of the vertex is always the same as the y, or the vertex. You notice the vertex equation is the same, the opposite of b all over 2a is the same as the axis of symmetry. Sorry, that's what I meant to say. It's the axis of symmetry. Your y value of the vertex, or in other words, k value as they often call it, is equal to 4ac, or 4 times a times c, minus b squared all over 4a. So you're going to be using these equations to calculate the vertex without ever graphing it. So let's try using those formulas. First of all, we need to identify our a, b, and c value from the equation of the quadratic. Your a is equal to 2, b is equal to 4, and c is equal to, don't forget the signs, the -8. So to find the vertex, or h, k value, H is the axis of symmetry equation. So the opposite of B, so that would be a negative 4 all over 2 times A. Well, our A value was 2. You will need to simplify that. So negative 4 all over positive 4 is equal to negative 1. So that's our H value, or the X value if you're thinking of X's and Y's. To find your K value, it's equal to 4 times A times C. So 4 times your A value times your C value. All of that, let's see, minus B squared, or 4 to the second power. That whole quantity divided by 4 times A, which is 2. Now there's a lot to simplify there, and you will need to use the order of operations to simplify this. So order of operations says you solve all your exponents first. Because of my limited space of writing, I'm just going to write the answer over top of it, but I would recommend on your paper to write it off to the side. Maybe write equals and then off to the side. Well, 4 squared is your exponent. You need to solve that first. That equals 16. Then you need to do any multiplication or division as you read it from left to right, so we'll need to do this multiplication right here. 4 times 2 is 8. 8 times negative 8 is equal to negative, 8 times 8 is 64. So if you can't see that clearly, I'll write it over here up to the side. Negative 64 minus 16 is what we have on our numerator. On our denominator, 4 times 2 is equal to 8. And now we take care of our addition and subtraction. So negative 64 minus 16, those are the same signs you have to add, but the bigger sign is still negative, no matter what there. So we have 64 and 16, that's, let's see, 10 carry 1, 6, 7, 80. All over 8. And then that would equal then 80 divided by 8 is 10. A negative divided by a positive is still a negative though. Negative 10. And that would be your K value, negative 10. So our vertex is at negative 1, negative 10. Because this is a positive value, that is our minimum. The vertex is at the minimum. And so, yes, we expect that our coordinates would be negative and negative at this lowest point. Let's try another one. Here they gave you the graph along with the equation. We can see just by looking at the graph that the parabola is pointing downwards, so it's no wonder that we have a negative x squared here, and that our vertex then would be located at positive 3, negative 2, which is what they want here, positive 3, negative 2. You can see how much easier this is when they do give you the graph. But if they didn't give us a graph, then we could use those equations. So our H value, or the X value of the vertex, is that axis of symmetry equation, opposite of B all over 2A. And our K value is 4AC minus B squared all over 4A. So our B value is the 6 here. So the opposite of positive 6 is negative 6 all over 2 times our A value, which if you look there is equal to negative 1. So we would have negative 6 over negative 2. And that would equal our positive 3. So we're just confirming that our vertex is at positive 3, negative 2, using our formulas. Our K value is 4 times A times C. So 4 times A, which is negative 1, times C, which equals negative 11, minus B squared. So that's 6 to the second power all over 4 times our a value, which is -1. To simplify that, I am going to go ahead and multiply this, but just then remember I can't subtract until I get my exponents. So 4 times -1 is -4. -4 times -11 equals +44. Minus 6 to the second power is 36. All over 4 times -1 is -4. 44 minus 36 is equal to 8, and over -4. So a positive divided by a negative equals a negative. 8 divided by 4 is 2. So there we confirmed our 3, -2, using the formulas. So here we are in our third example. Step 1, find your A, B, and C value. A is equal to 1, B is equal to -2, C is equal to -3. Your H value is equal to the opposite of B, so in this case it's going to be +2, all over 2 times A. So 2 times 2 is 1, 2 over 2 is equal to 1. So H is equal to 1. Our K value is 4AC, so 4 times A, which is 1, times C, which is -3, minus B squared. Our B is equal to -2. Watch what I do here. Because it's negative, this is important. I'm going to put it inside parentheses, because what will happen if you do not put those in parentheses, especially if you're using a calculator, if you write this and you put that in your calculator will only figure out what 2 squared is equal to, which is 4, and then you'll be subtracting 4. The difference between that and this is actually there. Sorry, if you had this and this. So because it would be minus a -2 squared, the difference between this and this is that you would get the wrong sign eventually. This right here is equal to +4, and then you would get -4, where your calculator on this one would say that this is equal to 4, and then 2 negatives make it a positive, and you get a +4 with your calculator. So whenever you're taking a negative number to any power, make sure you put the negative number in parentheses, especially when you're using a calculator. All over 4 times A, which is equal to 1. Right, so here again I'm run out of room, but I would recommend on your paper that you just write it off to the side. See if maybe if I use, can you see that? Oh, you can't see that purple on the black. Okay. So 4 times 1 times -3. 4 times 1 is 4, times -3 is -12. Minus, you need to do your exponents first. -2 squared is equal to +4. 4 times 1 is 4. It's equal to -12 minus 4. Those are both negative, so I would have to add, but my answer is still negative. 16 all over 4, which then equals, now I really am off my page here, which equals, when we reduce, -4. So this would be a -4. So why do we even care to learn about a parabola and the vertex? Well, parabolas are used in everything from satellite dishes, radio telescopes, dishes like TV dishes, solar radiation collectors. All those are uses. We also have parabolas in bridge making and any type of projectiles. When you get into physics, they want to know the highest point that a projectile will go. You also have submarines that need to know what's the lowest they can go at a certain depth based on their motion. So there's a lot of, in physics, there's a lot of use of the parabola.